So what is mutually exclusive and independent? We know what is an event, right? We have defined set of interest. But when we call it two events as mutually exclusive, so what does it mean? One occurrence of one prevents the occurrence of other. Very precise. Occurrence of one event prevents the occurrence of other. Okay. So that is mutually exclusive. What is then independency mean? We will have to understand what is independent. What is independent? Literally, independent events. What is independent? Two events. When do you call it as independent? Huh? What is dependency or independence? How do you depend? That's a very it's a English way of saying things. But what do you do? At least she is attempting. Others are sleeping. You can get up. Huh?
Outcome of one event will not affect the other.
I don't care. That is the final answer, right? Final option I gave you is I don't care. I told you I don't care whether you are there or not. So I am immune to you basically. I don't care whether A existed or not. B is independent of A. So B doesn't care about A. Whereas in the first case, B is definitely worried about A. If B occurs, A will not occur. A occurs, B will not occur. Right? So that is what independence is. Sorry, mutually exclusive. Mutually exclusive is highly dependent. They are highly dependent. Why? The moment A occurs, I can rule out B cannot occur. Period. So they are highly dependent. Whereas when you talk about independent, I don't know any. So tossing of a coin. What about the outcomes? Are they independent or dependent? Two coins I toss, first time and second time. First time I toss, you get head and tail. The second time also you get one of them. Are they dependent or independent? Are they mutually exclusive? Within a coin, it is mutually exclusive. When a head occurs, you can close your head and close your eyes and say tail has not occurred because only one of them can occur. But when you toss two coins, the second coin's outcome is independent of the first coin. Is this independent events easier to handle or difficult to handle? Easy to handle. Why?
Because there is no relation between them.
Then what is a data scientist doing there? Can we model them? That is the question. Can you model them? No, you cannot. When you say why? If my futuristic behavior is totally independent of the past, can you model me? Not possible based on my past. I give my past history, but my future movements are going to be totally independent. Behavior is totally independent of the past. Then you are lost. Anything which is completely independent, you will not be able to model. Right? Independent outcomes are the most difficult ones to predict. Okay. Thankfully in nature. So can you give me an example of a sequence of independent events? Apart from throwing of a coin and throwing of a die and tossing of a coin, give me examples of independent events. So that why I am taking some time to explain this is it is very hard in nature to find out totally independent events. Have you ever wondered in cricket, in a game of such a billion-dollar industry, you choose batting or bowling, which is a very important decision, just based on tossing of a coin? Have you ever wondered? Pitch report is there, weather report people say, pitch report people say. Now people are trying to keep embedded sensors inside the pitch to understand the humidity levels, etc. Right? Pitch report people are trying to do, measured pitch report, and then people are already doing weather report, player stats. But batting or bowling is an important decision. Everybody knows cricket here, it's a cricketing nation. But why do we choose by tossing of a coin? Have you ever wondered? Independent. You cannot model it easily. But again, if I tell the same statement to my friend Anil Prabhagar from electrical, he will start shouting. He says that can also be modeled, that is not truly quantum. okay. But for all practical purposes we can treat this as truly independent, okay. There also it is like Einstein's relativity versus general theory, I mean Newtonian mechanics. Newtonian mechanics F equals to ma holds. I can still say that tossing of a coin is a independent events and then stay with it. When it comes to quantum mechanics, that may not be a true quantum state, truly random in that sense. If you measure all the spin velocity etc., you can still predict it, okay. But which we do not do, it is very rare, it is not common practice. So therefore tossing of a coin is an example of IID, independent, but it is very rare actually, very rare to find out things which are totally uncertain, and that is why data science is ruling the world today, because there are hidden patterns, because there are relationships either in the immediate past or in the long range or short range, right. That is where today data scientists are valued and data science is flourishing purely because of existence of relationships, either linear or non-linear, whatever it is. If it is independent, you give up, because I do not have anything to tell about his future, because past is irrelevant, you are done, right. That is a very rare phenomena.
For example, the number of 6 hit by a person in first match and second match are dependent, but the number of 6 hit by person 1 and person 2 in same match, they are independent.
But why will I have a history? I can use that history to predict.
No, is it dependent person 1 and person 2?
No, even see, I am not talking about person 1. So if I have person 1's record, I can predict this person's record in the next game to a certain extent. In that sense, it is not an IID.
Person 1's performance is dependent, but person 1 and
Person 2, why would I be worried? Person 1 and person 2 may be independent, but I am not worried about that. I am worried about modeling him, right. You have to ask the right questions. As I told you, is life and death predictable exact to the timeline, to the exact date, time? No.
But you are calculating total number of 6 hit in a match.
Total number of 6 in the match, individual persons, if I do modeling, then I can sum it up. If I know some relationship, still it is better. The left and right batsmen go together. See, in RCB, take an example of RCB, a wonderful team of 11, put together, we know the result, right. Individually their players are extremely good, right. You ask any team strong, if RCB is not stronger, I would say no, definitely not. You see in them individually perform, how do they perform? Extremely good, right. So
those are dependent just because they can be predicted, is it?
There are patterns you observe from the data. These are not, I cannot know the reality, ground truth is never known in this case, but there are patterns evidently seen from the data, and based on that I make predictions. There are patterns. Are there patterns in tossing of a coin if it is an unbiased coin? No. So I am talking of that. To give you another example, have you seen baby, when you go in when your fan is noisy, sometimes you actually do better sleep. Have you felt sometime this generation? When your fan is noisy, have you ever felt? Right? Some of you might have experience, not all of them. Okay, this generation, my generation, definitely everybody would have had the experience. Have you ever travelled in a government bus, SETC state? You sleep well compared to a private bus. Why? Compared to where you are given an AC, where you have a Volvo bus, but you still sleep well in a government bus. Why? Your fan noise actually is truly random. Your movement there, your brain, so when your brain is not able to model, it shuts down actually. You cannot ignore it, so it shuts down. So when you have this fan running, have you seen the baby sleep well when they rock? Is there a logic behind it? What is the logic, will you explain? You put them on a very comfortable chairs, comfortable rooms, do they sleep? No, they cry. But the moment you rock, there has been the age old strategy, like you rock and they sleep. What is it? Why is it? Why does it happen? Any idea?
Making the baby tired.
Tiring, there are several ways of doing it. You want to rock and tire. Is that a reason? See, the movement itself is random for the baby. It's not always periodic, right? So in that sense, so whenever the fan noise, etc., the noise you kind of go in the state buses, transport buses, older buses, you kind of don't try to model it. Brain doesn't try to model, gets relaxed. It's actually white noise. We will learn it later. White noise is supposed to be actually soothing down, even though we put melody to sleep. But what so often I tried is I put a white noise, I am happy. Things get shut down, right? So the independent events is something which we cannot model, and it's very rare to see in reality. It's not often seen because in nature things happen over a period of time, it gets accumulated, right? What do you want to call it, karma philosophically or whatever, things happen as you accumulate, right? In nature you can always observe that, the accumulation effect. It cannot be a single point event, right? When you see water turns to vapor, somebody can say it cannot be modeled, but there is a history of heating. Although it is not evident, when you measure them, you know that the temperature is heating up and therefore it will become vapor. So it is an accumulation. So nature accumulates, and therefore that is the reason for data science is there. We are all looking at the past and trying to model the future. Okay. So independent is something which defies all of that, which is, so what is probability of A intersection B for mutually exclusive? 0. For independent, for independent, why not P of A plus B of B? Why not P of A plus P of B? Why is P of A into P of B? How does it come? For independent events, P of A intersection B equals to P of A into P of B. How is it? I know the answer is you remember, but do you derive? Do you know why? This is not an undergraduate course, although the material may be undergraduate. You have to look at it carefully, that is where things differ. So if I ask you y equals to mx, a 12th class kid will say ms slope. If you say the same answer, what does it mean? You are not grown. So what is y equals to mx? What is m here? Slope. Then now only I told. You said something better. That we will learn in this class. Okay. M cannot be, m is slope is a very naive answer. We will talk about much better. Many of you will not know it. Anybody know what is m other than slope? dy by dx is giving an answer. Huh? Slope we are interpreting for me mathematically. Is there anybody better answer? That is what we will learn. Okay, this is going forward, we should be doing that. So how do you say probability of A intersection B? What is probability of A intersection B for independent events? How do you get it? Okay. So mutually exclusive I talked about. So now that is where the next part is. We will look at, before we delve into independent events, we will slightly understand what is A intersection B. How do I write A intersection B? Any idea? Probability of A intersection B. Look at this figure. Can you write A intersection B? What is probability of A intersection B? What is here A intersection B? What is the region of A intersection B?
For independent, how it is? P of A.
That is what I am going to derive. That is what I am going to. I will not leave anything untouched. A intersection B, how do you know? Union minus A plus B is in A intersection, but I want from this figure, I want A intersection B. How do I define? I have shown you specifically a figure. So if B has occurred, then this can be removed. B complement can be removed. I want to search only in this area, right? If B has occurred, then I want to search only in the sample. So the sample space is the overall space, right. Now when I divide the sample space, how do I divide? I divide into B complement. A is both in B and B complement. A can occur along with B or not along with B, right. So that means A can occur in union with B or union with B complement. So now suppose I know B has occurred, then how does the search space prune to? Now I am looking for what is probability of A. Let us even look at slightly, okay. Let us look at slightly different. Probability of what is probability of A from this figure? Probability of B into probability of A given B. Does it make sense? Or again I can write probability of A equals to probability of B complement into probability of A given. Both are equally correct statements. Yes or no? Right? Agreed? Is this making sense? Everyone? Simple idea? Okay. So now if I rewrite this, how do I get this? How did I get this? From here I went to here. Probability of A equals to probability of B into probability of A given B. So now from here I will write this, copy this here, I write it as. How did I come up with this? How did I come up with this? Any idea? How did I come up with this? You see the formula? So this one is clear, probability of A equals to probability of B into probability of A given B. That is what this statement, and I can write it in same terms. But how did I arrive at this? Any idea how did I arrive at this? How did intersection come into picture? Is this A or is this A intersection B? Is this A or A intersection B? Is this A or A intersection B? Right? See, I am saying, okay, so this is, so first let us understand, this is probability of A intersection B. What is this? I am only interested in this region. Okay. So now B has occurred, probability of B has occurred. That means what? The sample space, this sample space is gone. Okay. B has occurred. So then I am interested in A happening, B happen, A happening along with B, which is nothing but A intersection B. So A intersection B is what? Probability of B, which is this region, into probability of A given B. Why multiplication? One followed by the other. It is not an additive effect. It is one, the superset is probability of B, and the subset of it is what? Probability of B given A given B. This number cannot be greater than probability of B. Agreed? Probability of B into probability of A given B cannot be greater than probability of B. Why? Remember, probability is less than 1, less than or equals to 1. So if probability of B is 0.6, probability of B given A, whatever number you multiply, it will be less than 0.6. Okay, and that makes sense. That makes sense by Venn diagram, because probability of B is a bigger set. Probability of A given B is a smaller set compared to. So probability of A intersection B is what this is. And now if I want to write probability of A, this is nothing but probability of A intersection B plus probability of A intersection B complement. And what is probability of A intersection B complement? That is this region. and this is nothing but probability of B complement into probability of A given B complement. Okay. So now if I rearrange this, what do I get? Probability of A intersection B, A given B is probability of A intersection B into probability of B. This is the conditional probability that A will occur given B will not, B has already happened. And now tell me what is probability of A intersection B when you are talking about independent events? For independent events, for regular event, what is this? Probability of A intersection B equals to probability of A give B into probability of A given B, or probability of A into probability of B given A. Now for independent events, what will happen? Probability of A intersection B. What is probability of A given B for independent events? What is probability of A given B for independent event? Probability of A. Why? I don't care about B. Independent means what? I don't care about B. Whether B has happened or not is least of my concern. So I don't care about B. So then what is probability of A intersection B? Simply A. So now this becomes what? Probability of B into probability of A. It is not 0. It is probability of B into probability of A. This is the reason why it is. Ideally it should be probability of B into probability of A given B for normal events, but for independent events A given B is nothing but equal to probability of A itself. There is nothing to be worried about B because A and B are independent here. Okay. So that is what this is all about. Does it make sense? Okay. So this is conditional probability, and conditional probability becomes very important. Why? Even in clinical engineering, everywhere. Why? Conditional probability, how do I represent it very nicely if I want to represent? Like a tree, and tree is something very common in what? You have heard of decision trees, etc., right? But tree is a very common representation in medical field because you start with the condition A. If condition A, then if not, then you go start deeper and deeper building the tree. So that is all nothing but conditional probabilities, right? So the decision tree, I mean the tree is a very neat way of doing conditional probabilities, and tree representation is very common in biomedical. Okay, because you start with gender this, age is this, then if this symptom is there, X, Y, Z, you build a tree, but that is nothing but conditional probabilities. Actually all of them are conditional probabilities, right? If X is this, that means if X along with this happens, then this is the desired, I mean this is the outcome. So if you say whether to call it as a heart related issue or certain kind of disease like this, they will put a big tree. Now they call it as decision tree, but the overall idea is it is conditional. If you look at even a tree, it is all the branches are conditional upon its root, right? A normal tree when you draw, I mean like this, a tree, even tree you draw, it is actually a conditional probability. The root is the starting point. Then you say root is greater, root has occurred, you take diversion X or Y, then this has happened, then again go till the leaf. So conditional probability is best depicted using a tree arrangement, which is very common in medical field. Okay. So you have learned about conditional probability earlier, everyone, or no? Yes, can you accelerate or? Right? Okay. So now these are some questions I have asked, so you should be able to answer. So this is what we talked about, multiplicative rule of and independent events. So multiplicative rule is this, and A intersection B becomes A or B intersection becomes B for independent events. Okay, and these are best represented using trees. Okay, so to give you an example, assume 3 of 10 workers give illegal detections in your tax, okay, finance, and then event A, first worker selected gives an illegal, event B, second worker, and probability of B given A, both, right. So now first worker, so let us draw this as a table, right. First worker giving illegal detections, what is the probability? So select first worker, and I have no one, no, this is totally how many, let us say, assume 3 of 10 workers give illegal detections. So what is the probability that the first worker gives illegal? I 3 out of 10, and then no as 7 out of 10. Now if he has given illegal, then what will happen? The second worker giving illegal detections will become 2 out of 9, 1 is gone, 2 out of 9 and 7 out of 9, right. Then you keep building the tree. Now you ask a question, what is the probability that both of them are given illegal? Very less, okay. Both of them have gone legal, higher, right, and these are midways, okay. So this is conditional probability, right. The root is the starting point and then conditions build on both the ways, okay. This, keep in mind that whatever fancy names you give, decision trees, etc., although the objective functions may be different, the idea is conditionals, okay. A tree diagram basically.